Good morning, class. So today we're going to be continuing our discussion on vectors. So remember the difference between scalars and vectors is a scalar is just a magnitude, whereas a vector is that magnitude with an added direction. So that makes it perfect for problems involving velocity, because velocity compared to the speed, where speed is just the magnitude, velocity then also includes a direction, like north, south, east, west. So I'm going to be borrowing this problem from Khan Academy. If you wanted more information on vectors, you can check out their videos. And this is one more problem that they have that we're going to be working through together. So let's read through it. So Amelia flies her airplane through calm skies, no wind, at a velocity, speed, and direction. V1. The direction of V1 is 15 degrees north of east, and the speed is 180 kilometers. So if we were to draw out cardinal directions, so north is up here, so east, south, west. 15 degrees north of east. So that means this way. Call that. So 15 degrees north of east, the magnitude of 180. Then, eventually she enters the windy part of the atmosphere and finds that the plane now moves at velocity v2. The direction v2 is due east, and that speed is 150 kilometers. So the plane ends up in this direction, east, the magnitude of 150. If you notice, one mistake I made right now is, if this magnitude is 150 and this magnitude is 180, shouldn't this vector be larger than this vector? Yes, if we're trying to be consistent. So let me enlarge this one, because I don't want to make things smaller. And that should be fine. Right? As long as we understand that this vector has a greater magnitude than this vector. And then that means there's some resulting wind, which we can represent with it by this blue vector that gets us here. So it slows us down, and what we're going to be trying to do is calculate that vector. So the very first thing we want to try to do is write the vectors. So let's look at 180. We're going to look at the first one, v1. So v1 can be written as 180, the magnitude. If you guys remember, if we have a triangle, you can always make that into a right triangle. It would degree 15. Hypotenuse 180. We have x and y. X and y. Right? Remember, but from SOHCAHTOA, then we can see that the adjacent side, the x component, would be 180 cosine of theta, which in this case is 15, so cosine 15. And we can see that that y component is going to be 180 sine 15. Let's make that. So let's plug that into our calculator, which I do not have open, so let's open that up. So let's do 180 times cosine. Whoop, that's not how that works. So 180 times 15, make that into cosine. That's what we wanted. This is the value of cosine. So now we're going to equals, and that's going to give us our value, 173. So first vector has a value of 173.867. Our x component. Right? And then our y component would then have 180 times 15 sine of that, 46.587. Nice. Now let's find out where our resultant vector is. So in this case, the red one, where we ended up at. So we have this triangle. Does it have an x component? Does it have a y component in this case? It's just going straight east. So in this case, if we were to try to draw a triangle, we would only end up with a straight line. And on the grid, you can see that it would have, since it has a magnitude of 150, this distance here is 150. This distance from here to here. And there's no y component. So this one's easy enough, and we're done with the two vectors. And then we can relate these two vectors together. Let's call this one, I guess, v3. Continue the pattern. So in this case, we could see that v1 plus v3 equals v2. From our picture, you can see you can go up, down, and go here. Or even if you had started with v3 going this way, and you went up v1, you would still end up at where v2 is. So that's the introduction to this word problem involving vectors. If you would like to see the full video where we go over the problem in its entirety, click on my face. Aside from that, I hope this was able to help you set up the word problem and understand vectors a little bit more. Thank you for your time. Have a nice day. Bye.